just disappointed now.
Your production team is not
Not the very best. It's not working or it's working?
It's working.
Okay, perfect. Working, right? I don't know. I can't see it there, so that's why I'm like.
He's trying to see if it'll refresh. It's not showing up yet.
Okay, and then you say contract state, and then you open this up. You understood, right, why I did contract state? Because we initialized it with T here. Right? Now, what are we writing inside? We're first going to take a temporary variable, calling it current counter. Okay? And here we are going to do self dot counter dot read to get the value of the current counter, right? You're getting my point?
Yeah.
And then next we are going to do, then we are going to initialize now storing the new value of the counter, right? So it's going to be current counter plus 1. And then we are going to use the self dot counter dot write function. Sorry, dot write of inside this we are going to write the new counter.
Got it. Yeah.
Okay, pretty simple.
Yeah.
Right.
Yeah. And it still follows this same interface, contract, and then ABI. Right?
Yeah, ABI.
ABI.
Yeah.
Which was the implementation.
It does not return any value, it just updates the value, right? Okay, so I did wrong here. Doesn't return any. Okay. Right, and next is now the same with decrease as well, right? If I just copy and paste this, change the name to decrease counter, right? DECREASE, decrease counter, self reference, current counter, we are reading the current counter. Now instead of that we'll do -1, okay? Like instead of addition we are doing subtraction because we are decreasing the counter, and then self dot counter dot write new counter, right? We're writing the new counter. But here something that you need to understand in the deploy decrease counter, because there is a potential issue here. The decrease function can trigger an underflow. You're understanding? Like it can go less than it can go less than 0. The moment it goes less than 0, it becomes a signed integer versus
Won't it break because it's not
exactly, which is why we have to like protect it, right? How do we protect it? But before declaring the new counter, here we actually say assert. So we'll make an assertion saying that the current counter, yes, the current counter greater than 0. Otherwise, you say counter can't be negative. Right?
Yeah.
And then semicolon. Yep, that would protect us from the underflow. Okay, next up I would want to talk about, now I am going to put this constructor here. I did put it there. Okay, and next up we are going to talk about events. Now every time we do internal modifications, right, we should launch an event like that records this modification. For example, if we are decreasing a counter, increasing a counter, anything that's happening in our application should be indexed, right? And how can it be indexed? basically events, they are defined using enum. Okay, the enumeration, the custom type that we talked about, they are defined using an enum. But above that enum, what you do is you write hashtag bracket event like this, just to say that this is an event that is recording the what is happening in the counter, right? Am I in the right? Okay. Wait. Yeah. So how can we say that now to let the compiler know that this is not a regular enum? How do we do that? We're using the hashtag event, right? Now the event attribute needs to have some extra hints also that says this is a Starknet smart contract event. So how do we do that? It's going to be first thing you will say event, right? And then the next one would be hashtag divide bracket. Now we're adding the drop property as well as it's a Starknet : event. Okay. Wait a minute. Okay. This way, and then we say now every time the counter is changed, that is where we can add an event, right? That indexes what is the change that's happening in our application, because our application is changing the counter. So we will just do counter change, right? Just a second. Struct counter changed, and then in this struct we are going to say counter changed colon is of the type counter change, and then we are going to now we also want to record a couple of things, right? We want to record the caller who is calling this contract. So we will call the contract address, and to call the contract address we need to also define this. I will show you in here, right? In the use Starknet, we're going to say use Starknet : contract address like this. Okay, this will give us the address where the contract is deployed. Okay, and that is where who the caller is. Now the next thing would be recording the values that is getting changed, right? So we can say, what happened here? This is not sorry. This is inside the smart contract. It should be. This is the implementation. I am going to paste this here. Right, and now we are calling public. We are also recording the old value, which is going to be a U32 of the type U32, and then we'll also record a new value which is going to be of the type U32 again, and then we're going to record, sorry, not here, we're going to say, then we're going to record the reason why this value was changed, right? And we're going to say, like, we're going to call now another struct that will define the reason. This is basically like an enum that says what the reason is, right? And these events, they help us keep a track of everything that's happening on our smart contract. The history is getting recorded here. This is where the history is getting triggered, right? You're calling these transactions. So how would you know that an event is getting triggered? Now, I cannot show you how an event would look like on the front end, because Scaffold UI is still developing that part where you can actually see these event changes on your local DevNet. But in case you're doing mainnet deployment, right, then you'll be able to see it on a block explorer. All of these events getting triggered, right? Now next up is again since we did change reason and it doesn't have a change reason, I am going to 1 minute hashtag okay. I'm going to copy this, drop copy comma. So if you remember, copy is from the copy trait, okay, and what does survey means, basically this helps serialize the value. So because we do not have any specific like definitions of how this value is going to work, which is why we are going to declare an enum and call it change reason, right? And then 3 things that would be here is, one is you want to trigger change like the reason that the counter was changed was can be increase, another reason could be decrease, another reason could be reset, and then another reason could be set, right? You're setting, resetting, decrease and increase, that's when the counter is getting changed, and this is being called here. Now counter changed, wait, it says it must be named event. Why is it not named event? Okay, it's trying to authenticate me to GitHub. I think I have 2-factor authentication on, but just a second, let me extend the screen. Show down there. Okay. I'm going to put that in and put this here because my device is getting ejected multiple times and I don't want that to happen. Why can't you see my screen? Okay. There is some issue with my laptop, but I can show it to you here.
Sure.
Okay. So here's the thing, right? Now we just defined an event that records who the caller is, the old value of the counter, and the new value of the counter, and why this was changed, like whether the increase function was called, the decrease function was called, the set or reset was called, right? So how do we now get this event to be called? We defined the event, but the event is not being triggered anywhere, right? How do we get it triggered? So inside, like we wrote increase counter, right? Increase underscore counter, and then we did reference self colon contract state, remember? In the definition, right? And then we opened this up and we said we simply like called the current counter, right? By saying self dot counter dot read, right? And then the new one was let new counter, and I'm talking about the increase function. We will see how we are implementing this in the decrease one as well. But in the increase one, we did let new counter equals to current counter plus 1, okay? And we said self dot counter dot write finally. I think it restarted. Yeah. Okay, and then we said self dot counter dot write, which became, and then here we wrote, here is where we wrote the new counter, right? We passed the new counter value here to set the value of the counter, right? Okay. Just a second. For a second, I'm going to close this so that you do not see any of it. And then how do we now trigger this event, right? That's the more important question. So to trigger this event, we define it here only. Now after setting the counter, we need to trigger the event to like record that the counter was increased, right? So we do let event, and then we write colon of the type, the name of the event counter changed, okay? And then we say, now because it was a struct, we have to define all of the values that we were, like we need the caller value, the old value, the new value, right? So how we are going to do? Counter changed, open, and then now we are going to define what the value of each value was, right? This is basically current counter, like the old value, right? Current underscore counter, and then we say the new value is the new counter, okay? And then the caller is, because we needed the contract address, we are going to say get caller address of, right, and comma, this is a comma, this is a comma, and then we are calling the reason now, like why was it changed, you call change reason, and then you say the reason why it changed, why is it changing, with the double semicolon, right? Sorry, with the double colon, and then you close this. So what does this basically mean? What are we doing here? We're doing nothing but increasing the value of the counter and then calling the event to tell it that the value of the counter was increased by this person, old value was this, new value was this, and the reason was this. You will do this in the decrease one also, you will do this in the set value, get value, in all of them, so that you know when your counter is getting updated and all of it is recorded on chain, right? That is the whole reason that we are doing this. Now, this is done. The only thing that is missing is we do not yet know the. So the only thing that would be missing here, no, there, like, yeah, that's pretty much it. Okay. There's nothing missing here. We would do the same thing for the decrease counter as well, where we are only going to change the reason to decrease. Okay. That's it. Now, another function that we would write is the set value of the counter, right? How do you set value for the counter? Now, just to complicate things, we can also define it such a way that not everybody having access to the smart contract is basically, getting the authority to set the counter. Only the owner has to be able to set the counter. So how for set function, again repeating myself, set function, what are we going to do? We are only going to let the owner call this function. Everybody else, this function is not available to you. You're getting my point? That is where we are adding the barrier of like authority, right? Where if they are the owner, then only they can call the set function. Okay?
Okay.
Now, what are we going to do here? In the storage of the smart contract, right, where it was said storage, right? We defined the storage, struct storage, right? Yeah, it was like counter U32, right? Here we are going to add another value that says owner colon contract address, and you know where this contract address is coming from, right? We said use contract use Starknet colon contract address. So Starknet basically has that, like, use Starknet colon contract address will directly give you the address of this contract, like where it is deployed during that time. Okay, so this will record the owner, and anybody apart from this contract, like where it is getting deployed using whichever account it is getting deployed, right? Nobody else will be able to basically, like, this is where the owner is getting defined, and once the owner is defined, then you cannot change. Like if you are not the owner, you cannot change the value of the, like, set the value of the counter. You can definitely increase and decrease it, but you cannot set it, right? Yeah. Next up, if you see, now that is where we add the counter, and then post that we are post all of this, the only thing that we are going to be doing is calling the set function and only allowing the owner to call the set function, and that's pretty much it, right? So how do we allow the owner to write the value? If you remember, the constructor is what sets the function, right? Sets the value of the counter here. So what we are going to do for the constructor, we are going to say hashtag constructor. Like this is something that we have already, like, defined, right? And then it was function constructor, and then the reference self colon contract state, and then there was a init value as well, the initialization value basically that we were sending it from here, which was like we were calling it here, like U32. Another attribute that we will add here would be the owner address, right? Or the owner. We'll call the owner and we'll say it's the contract address. We will add them here. Okay. The reason we are able to call this is because we have added it in the like the storage, right? So it will just fetch the value here. You open it up. Now all you do is self dot contract dot write init underscore value, and then self dot owner dot write. Now self.owner.write will tell you please verify if the person that is writing is the owner. That's it. So now your constructor, which is initializing the value, can only be called by the owner. That is it.
Okay.
Right?
Okay.
That is how we are implementing this.
Okay.
Now, to be able to track ownership and have a bunch of functions connected to ownership, we could implement all of it manually with the smart contract. For example, how do you change ownership and how do you renounce an ownership, right? How do you renounce ownerships? Or we could use something. Now, this is what we wrote here, right? Manually wrote it here. But Starknet again has functions that let you directly call owners. You do not have to define all of this, do self.owner.write and then call owner and all of this. In this case, that is where Open Zeppelin comes into the picture, right?
Sorry?
Open Zeppelin.
Open Zeppelin.
Have you heard of Open Zeppelin?
No.
Can you Google Open Zeppelin?
Not at all.
Okay. Let me show it to you. Okay. So what does it Open Zeppelin do? Open Zeppelin basically it provides a library. Okay, it's like a library, and it's not just Starknet related. It's for all smart contracts, right? All language smart contracts. It's basically a library that provides for the secure development of smart contracts, and it also gives you these packages, right?
So not different from Node or React.
No, they're not different from how it basically gives you reusable components that are already defined that you can simply call by just writing this one command in your folder, in your Starknet, in your smart contract, right?
Mm-hmm.
And you say use Open Zeppelin. Okay. And Open Zeppelin underscore access ::ownable. And how do you find out that this is there in the Open Zeppelin library? You just go on to you just have to and because Open Zeppelin provides support for Solidity, for Rust, for every other smart contract language, right? How do you find out specific to Cairo? All you do is Google Cairo smart contracts Open Zeppelin. It will give you all of the functionality that it enables for Cairo smart contracts, okay? And what you can do then to enable that into your project, right? All you have to do is add that package in the scarp.toml or Open Zeppelin, whichever version is there, and it's showing on the Open Zeppelin website which version is you will be using under dependencies, and then you use it here in your smart contract saying use Open Zeppelin underscore access. And why we are choosing ownable and the ownable component, because this is the one that gives us the owner. Now if you read the documentation, you would know this is the one that allows us to look at bring the owner, check the owner of the contract, right? It's basically a reusable piece of code that we can plug into a smart contract that and we can have multiple usable things for free, right? So we are going to use this, and then we will use a macro called component. Okay, so we are going to say component, okay, colon, exclamation mark, bracket, path, colon, ownable, and then we are calling the ownable component, okay, and then we are giving it the storage access, which is our which is the ownable this thing, right? This one, we're storing it in the storage as ownable, and then we're calling the event. Okay, this is marker is not working. Okay, and then we're calling the ownable event. All of this is present in that documentation where you can find out what's happening and everything, right? So this basically is telling us inside our storage, the hashtag storage that we had, right? The inside the struct storage, we are going to actually now, because this is an Open Zeppelin component and not our default storage that we defined, right?
Yeah.
We will have like a counter which is U32, right? Now here is where we are going to define we are going to do another hashtag, like not the hashtag, and then go do this and then say sub storage and bracket will say V0, which means version 0, right? Okay, and then here is where we are going to say ownable. Will need the ownable we are calling the ownable component, which needs which will give us the storage basically. Colon storage. You get my point? This attribute is basically telling the it's literally an attribute that tells the compiler just fetch the ownable component and the storage of the ownable component, right? And it's a sub storage, that's why we have added it there. Now we can also add like an ownable event in the like the smart contract that will basically track wherever like we are using the ownable, wherever we are using the owner address thing, right? Every time you call that function, an event can be triggered. Okay? Okay. Now it's pretty simple. If you look at the internal documentation, you will understand that this is nothing but a trait that's again defining the implementation for the storage, and then also like remember how we have to like do self.owner.write, check if it's the owner and all that. Now it looks simple because we are running the counter contract. But what if it was like a full-fledged application, right? And you're multiple times you are verifying the authority of the or how much access control this particular person has. So how would you do that? And that is when Open Zeppelin's like reusable components come into the picture, so that you don't have to like go to minute details and understand, right? Now next up would be like we talked about, like how we have to change we have to call the owner in the constructor. Like here also you have to like call ownable.initializer in the basically in the how do I say this inside the constructor to use this ownable component, right? Now you can easily like read the value of who is the one implementing this counter and then call the set counter function. Okay. There's also, if you look at the documentation of Open Zeppelin, right, there is all like, because I talked about how do you like, now we read the value of the owner, how do we change the owner, how do we remove an owner, how do we add another owner. All of these we have reusable components in Open Zeppelin that can easily be used to like perform all of these operations. Okay, next up would be, and we can even implement and now since we are running out of time, I would like to like quickly wrap up, right? We can also implement a function called reset, where anybody who's not the owner can call the reset function by paying some amount, like paying some stack, right? And we had all of those pre-deployed stacks and stuff, right? So apart from that, I think that's pretty much it that I wanted to cover. We did testing, you know, we did we implemented a smart contract. I showed you how it works on the UI, that minute UI problem that I'm having. Pretty sure it's because of like because my system doesn't have memory and it's like timing out, right? Which is why when I click refresh, I'm able to see it, but like, but I'll have, I'm pretty sure that's a system issue that I am particularly facing. So I will figure that out. But like the UI that I showed you when I was reloading, that's the UI that should stay there and allow you to call these functions, test out your smart contract, and anything above this would be just, you know, plug and playing with AI and trying to like build the front end. So if you see our project directory, it's very beautifully like separated, right? So Next.js, everything that's on the front end is there. SN Foundry, everything that's in the smart contract is there, and all of these is connected together. So all you have to do is just yarn compile, yarn deploy, and then yarn run, and yarn start, and then you'll be able to start seeing it on your this thing. Now, in terms of the hackathon that we're going to, like we're doing the Resolve hackathon, right? That's happening in February. I did give you. Did I share with you the problem statements?
You sure? Not the link, but you showed me.
Yeah, I showed it on the computer, but I will share it with you today, like with all the resources and the documentation, as well as like links to this GitHub repository also, right? Where I have like written all of the contract, executed it, and you can easily pull it and stuff. Other than that, any questions? Any feedback? Anything?
No, it's I mean, there's a lot of nuance and detail between the thing. But there's the general structure I understand. It's gonna take a few stabs to figure out.
I know, right? You have to go back and
really,
you did see like how debugging looks like, right? You have to go a little bit back and forth, understand versioning and what is actually wrong with because this is where a very critical, like it works on my system but doesn't on yours because of versioning issues comes into the picture, and that's the whole reason we talked about Docker, right?
And even that is good was good for me to sort of see it and witness and sort of understand the carry, the lift, right? To learn this is not.
Yep. But with this, you will what we wanted to achieve from this, right? So-called 3-day thing that we're calling it, was that you are able to basically understand the fundamental structure of a smart contract, and like, because sometimes, right, some issues might come in where you do not understand what's happening. When you read that issue, it would like how I was debugging just a couple of minutes ago, right, where I'm reading that storage is missing this, or this is missing, like this particular component is missing this. That's when you would understand. Now, when you read those errors, you will be able to understand, okay, this is talking about the storage of the smart contract, or this is talking about the interface of the smart contract, this is talking about the the smart contract module itself, right? And then you can make any changes, implement any kind of like functions and stuff. You do not need to know like the nitty-gritties of like how this is like what you want to write inside, but like how this works all together, right? How this is like fundamentally getting like how this is like coming together, right? How everything is attaching itself together, right? So I think that's pretty much it. If you have any questions, like feel free to reach out. I will be more than happy to help. Okay? Good job.
Yeah. No, it's oh my gosh. There's a lot to it. But it's broken down into more digestible bits.